Pinterest. It has a way of pulling you in with visually inspiring images similar to Instagram, but it's less about a particular person and more about an object or an objective that you want to achieve. I'm going to be looking at popular pins in home improvement, architecture, and design and debunking them. The first thing we're going to look at is shiplap. This was made popular on HGTV and is now used as a universal word for any wood paneling on a wall with reveals, similar to how Kleenex is used for tissue paper. But shiplap is actually a term for a very specific type of product. It's not plank wood, which has straight edges. It's not tongue and groove, which has an extruded piece that slots into the groove of another panel. Shiplap is a board that has a special rabbet or a notch cut on the edges of the board in an alternating fashion. These boards are meant to be installed horizontally because gravity pulls the boards down and creates an even gap or reveal. The boards are also designed to self-space, so you don't have to worry about the gaps being inconsistent. The rabbet or the overlap also prevents water from getting behind the boards because the joints butt up against each other. If you really want to install true shiplap in the vertical direction, you'd have to install furring strips behind the boards to nail them into because your studs are either 16 inches on center or 24 inches on center. Because of the hashtag shiplap popularity, Pinterest is filled with posts about shiplap walls, which are actually faux shiplap walls. They're just wood planks. True shiplap is a little bit expensive, so people buy 4 foot by 8 foot boards of MDF or plywood and they cut it down into strips. Or they buy 1 by pine boards and they nail them into the walls. But those strips of wood don't have rabbeted edges, so they aren't self-leveling. So people resort to using coins or tiles as spacers, which isn't going to guarantee you an even spacing because you're balancing an 8-foot piece of wood on a coin that can move. Furthermore, pine boards and plywood can shrink and swell, so they can warp in both thickness and in length, and they can even bulge out. Another issue is using planks of wood with gaps in bathrooms and areas that are prone to moisture. True shiplap is waterproof, but just nailing planks of wood into your walls isn't. People interested in a low-cost alternative to shiplap really need to look at beadboard. Some people think it's dated, but I really don't think it's that much different than faux shiplap. The advantage of beadboard, other than its low cost, is that you can buy it primed or pre-painted. You can even use a vinyl option in areas prone to moisture, like bathrooms. Beadboard is a continuous surface, so water won't get behind it and dust won't accumulate in the grooves, so it's easier to clean. The next thing we're going to look at is designing homes around trees. This idea was pretty popular when I was in architecture school too. It supposedly brings you closer to nature. Integrating a tree literally in your design makes the man-made and the natural one. At least that's the intention. The reality is very different. Trees need enough sunlight to grow. They need breathing room. They need insects for pollination. They need oxygen to survive. Their roots grow both horizontally along the surface and vertically into the earth. If you build too close to the tree trunk and cover the roots with your foundation, the tree is going to die. It seems like a great idea when it's just a small plant with shallow roots, but what if that plant does get enough sunlight and grows rapidly into a tree? You start having issues with the roots, something that's easy to forget in the beginning. Roots can be very destructive to a building's foundation. If roots grow too close to the surface, they start pushing your foundation up. I visited New Orleans in December, and the city has beautiful, massive oak trees lining their sidewalks. They must have been small trees when they were planted and they were tameable, but now the roots have completely taken over the sidewalk and pushed the concrete slab up at least a foot in certain areas. Nature always wins. You can try to contain it, but it will overpower a man-made structure. Even if the tree roots don't push your foundation upward, it will suck out all the moisture in the soil and cause the soil to dry out and compress. So the earth separates from your foundation and it doesn't have anything to sit on. It can become unstable and crack. Pier and beam houses where your home's foundation sits off the soil is a better alternative than slab-on-grade foundation if you are planning on building around a tree, but you still run the risk of suffocating the roots by restricting access to oxygen. Also, there's an increased risk of termite damage because you're bringing organic matter into your home. Very closely related to this topic are vertical forests or tree-covered skyscrapers. Another good idea in theory, but not so good in practice. Vertical forests involve planting trees in the balconies of high-rise skyscrapers to help purify the air, reduce smog, filter out noise pollution from the city below, and also help with climate change, apparently. There's a building in Milan, Italy called Bosco Vertical that's a case study for this idea. 2 residential towers were packed with 1,000 trees, 5,000 shrubs, and 10,000 additional smaller species. Botanists and horticulturalists worked with the architects and engineers to select specific plants and trees that would be most likely to survive on a skyscraper. The problem with vertical forests is that the designers are just trying to prove that humans and trees can closely coexist without questioning the validity of their approach to this issue. The structure of the building has to be over-designed to bear the weight of these heavy trees. They had to use extra concrete and extra steel reinforcement to make the balcony strong enough. The wind load on higher levels of the skyscraper is another concern. The trees might have to be strapped down to prevent them from tipping over and falling to the ground. Roots are another issue. You can't plant a tree in a small box and expect the roots to be happy when the tree grows. They need space and they're going to outgrow their planter boxes. And then there's the ethical side of this. Uprooting trees from their native habitat and planting them in a foreign, unnatural environment can cause them unnecessary stress. They're living things. Next up, container homes. I think I've beaten this topic to death, so let's move on. Reinventing windows. The architect Frank Gehry is known for designing extruded window boxes on many of his projects, including the Strata Center on MIT's campus, Sydney's University of Technology, the Vontz Center at the University of Cincinnati where I went to school, and the Dancing House in Prague. Water is the main enemy of a building. It wants to find a way in. Windows are typically inset and have a sloped sill to help water move away from the building. Trying to reinvent windows by pushing the glass to the outside of the frame is essentially an open invitation for water to get in. Water droplets that sit on the glass or on the protruding frame aren't driven away. The top edge of the window, which is exposed to rain, is very vulnerable. There's also an unforeseen issue with designing windows this way. When it's cold enough for water droplets at the bottom of those window boxes to freeze, icicles are formed. One of Frank Gehry's buildings in Cleveland reportedly had stalactite-sized icicles hanging from the roof's edges. The Vontz Center in Cincinnati had water leaks every year when I was there, and they still hadn't found a permanent solution to fix this issue. MIT has sued Frank Gehry because mold grew on the building's exterior and snow and ice accumulated on these window boxes and then slid down the facade. What we can take away from this is to be cautious of trying to push the limits when it's really not necessary. Standard windows with proper flashing details that would drive water away from the building would have made these projects so much more successful. It is dangerous to get stuck on the form of a building or a building component when their function should really take precedence. Glass skyscrapers. Glass is undeniably one of the most versatile and important human inventions, and it's now become synonymous with skyscraper facades. How else would you be able to stand hundreds of feet in the air, protected from natural elements, and have a 360-degree view of the city around you? At the same time, to a person at ground level, it is fascinating to see the city reflected in these skyscrapers. Glass buildings have come to represent state-of-the-art, modern, sustainable architecture. Visions of cities in the future are always filled with glass-clad buildings. But let's look at the properties of the material and question whether it's an appropriate cladding. There's a term thrown around in the construction industry called R-value. It's a way to measure how well a material restricts the flow of heat from one side to another. I'm going to use the analogy of clothing to explain this. A regular t-shirt would have a low R value because it doesn't contain your body heat and it allows cold outside air to pass through, similar to a single pane window which you would find on many older homes. A sweater would have a higher R value because it does a better job of keeping out the cold air and keeping you warm, similar to a double pane window which is used in most modern home construction and in all skyscrapers in the States. A big ski jacket would have the highest R value because it keeps out almost all the cold outside air, similar to a thick brick wall with an R30 insulation. Now, by examining those three levels of insulation, you can logically come to the conclusion that cladding a high-rise in glass isn't the best solution. The building is going to lose a lot of conditioned cold air in summer and is going to lose a lot of conditioned warm air in winter. The energy consumption of an all-glass skyscraper is going to be much higher than one clad in metal. It isn't as environmentally friendly as it's perceived, And also, it's pretty difficult to control the temperature evenly in a skyscraper because someone sitting really close to the glass in summer would get much hotter than someone sitting further away from the glass, someone closer to the core of the building. I understand the appeal of having floor-to-ceiling windows, but we should question the cost of that view. Shouldn't we move towards smaller, more defined windows and a more restrained use of glass if it's going to be better for the environment? The huge gap I'm seeing right now between residential and commercial construction is very ironic. When you build a house, your contractor tries to sell you on spray foam insulation, which will seal your building, give you the highest possible R value, and lower your energy bill significantly. At the same time, commercial contractors are designing very inefficient, energy-guzzling glass skyscrapers and don't seem to care about the R value at all. There are some pretty funny/horrifying stories about glass skyscraper failures. A hotel in Las Vegas gave guests lounging by the pool severe sunburns because the curved glass facade acted as a giant magnifying glass. There's another glass skyscraper in London called the Walkie Talkie that melted cars, fried bike seats, and scorched pedestrians because, again, the facade acted as a concave mirror and it shot death rays onto the street below. They fixed the problem by installing shutters on the glass, but the building has now earned the nickname Skyscraper. Okay, that's all I have for now. I hope you enjoyed that. Let me know if I missed any of the popular pins that are questionable. Don't forget to like this video and subscribe to my channel. Thanks for watching. See ya.